hello. Let's have some coffee and some pancakes. Welcome again to my channel. Math is Fun channel where you can learn a lot of things about mathematics and you will be able to improve your performance in the teaching and even in learning mathematics. This channel is intended an educational channel intended to those students or viewers who would like to improve their performance in math and also to eradicate math anxieties. So, welcome once again. This is Mr. Alistair Apalek, alias Emma Watson. So happy to see you again. So now we will have another things or new things to learn about mathematics. But before anything else, I would like to remind everybody to watch the video before you subscribe. And do not forget after watching, of course, as I have said, after watching the video, please click the button subscribe. And also another thing, I want you to just click in subscribe, click the all so that you will be multiplied, so that you will be able to be notified once there is a new video that will be uploaded in my channel. In short, the yellow bell button, kindly click it so that you will be notified. Another thing also, if you like the video, even if you don't like the video, please click like, and then you can share it to your classmates, especially those who are in need of a lesson or discussion about mathematics, especially those who are doing modular approach and online. Okay, so are you ready? I hope you're all ready. I'm so fresh as of this moment, fresh from the bath. I just took a bath, so I will now share the screen for our discussion, this uh, video discussion in this session rather. Okay, so now before anything else, let's try to recall about the loss of exponent in simplifying the following expressions, which will be our main focus this, and which will be related to our main focus in this video discussion. Our discussion will be something related to radical. I'll tell you the title later once we are already once we are done with this reviewing how do we simplify each expression. Again, to simplify each expression, we apply the laws of exponents. We have the product rule, we have the quotient rule, we have the power of a power rule. Sometimes we use the negative exponents rule or zero exponents rule. So this time, let's try to simplify. For number one, how do we do that one? How do we simplify that? Okay, check. They have the same base. So copy the base and add the exponent. So we have 7 to the power of 3 plus 2, which is 7 to the power of 5. I'll just write so that you can follow. 7 and then to the power of 3 plus, sorry, 3 plus 2. Okay, that gives us 7 to the power of 5. And then it gives us an answer 16,807, which is 7 to the power of 5. Okay, so that's how we do it for in simplifying number one. What about number two? Oh, that's division. So we will just subtract the exponent to what? To the numerator. So we have 11 to the power of 8 minus 6. That gives us 11 squared or 121. I hope you can follow. Again, 11 to the power of 8 minus 6. That gives us 11 squared, which is equal to 121. Okay? So I hope you can follow. Next, this one, 3 squared, power of a power rule. How do we do that one? Oh, 729. How did we get 729? Recall, in the laws of exponents, you multiply power of a power rule, multiply the exponent by its exponent outside of its parentheses. Then you have it 3 to the power of 6, and 3 to the power of 6 will give us 729. Okay. Are you all okay? I hope you do. And this expression, okay, let's proceed to the radical. Square root of 75. So how did we get 5 square root of 3? As our review in our previous videos, to review our previous videos rather, we just have to evaluate this one by looking for factors, two factors, smaller factors for 75 that gives us, or make sure that one of its factor is a perfect square. Then we have it 25 times 2. Then separate it, get the um, square root of 25, that gives us 5. And another thing also, of course, sorry, it's not 25 times 2, it's 25 times 3. Sorry. Okay, 25 times 3 as its factors, or two factors. So we have it, square root of 25 is 5, and then there is no, 3 is not a perfect square, so just remain it inside the radical. That's why the answer is 5 square root of 3. Follow? Okay, I hope you do. And for number 5, that is um, um, 2 square root of 35 over 7. How did we get it? How did we simplify it? So to simplify it, of course, we need something. uh, Rationalize. How to rationalize it? So just multiply both sides, both numerator and denominator with square root of 7. Multiply it by, rather, square root of 7. Why? Because we want to eliminate the radicals in your denominator, because it's not considered as not simplified if there is still at least one radical sign in your denominator. So I want you to remember that one. After that, we just have to 7 times 7 times 7, denominator times denominator, square root of 7 times square root of 7, which gives us square root of 49. And square root of 49 is 7. Got it? And 20 times 7 will give us what is the product when we multiply 20 times 7. That gives us a square root of 140 for the numerator, this one. Square root of 20 times square root of 7 is square root of 140, and try to look to for a factor of square root of 140. Okay, so what are the two factors that gives us square root of 40? We have 4 and 35. So 4 times 35 will give us, of course, 140. So meaning to say, square root of 4 is 2. That's why we have 2 here outside. And then 35 is not a perfect square, so remain it inside in the radical. So our answer is 2 square root of 35 over 7. So easy, right? All you have to do is just to apply the laws of exponents and also some of the expressions related to radicals, the multiplication rule and the division rules for radicals. And also please do include in the division of radicals about rationalizing the denominator, and also of course the conjugate. So those are the things that can be applied in simplifying each expressions related to expressions with integral exponents and expressions having a fractional exponents, or shall I say radical expressions. Yes! So easy. This is just a review. Okay, so our topic for this video discussion will be, or will focus on, the radical expressions and rational exponents. Are you ready? So you are all ready. I know that because I can see it in all your requests. I can read it rather in all your comments in the video discussions that I had before. So now, before anything else, we let's have first to find out all the square roots of 25. What are the square roots of 25? So square root of 25 is equal to x squared is equal to 25, which gives us x is equal to 5 and x is equal to -5. Okay, another thing, find all the fifth roots of 32. So fifth roots of 30 is something more challenging. So x to the power of 5, we all know, is equal to 32. So we just rewrite it in have a review about this perfect squares that we had before. X to the power of 5 is equal to 32. Then x is equal to 2, because 2 to the power of 5 or 32 can be expressed as 2 to the power of 5. That's why the fifth root of 32 is equal to 2. Or x is equal to negative 2. So next, um, x equal to negative 2 is not, sorry, those who answer the same as negative 2. Negative 2 is not part. Why? Because we are looking for the fifth roots. It's just only intended for the square root. We are here, or we are looking here in number 2 as the fifth roots of 32. So meaning to say, negative 2 is not part of its roots because we are not looking for its square roots. Do not forget that one. We are not looking for square roots, just like in number 1. That's why it has it considered the negative 5. For in here, number 2, since we are looking for the fifth root again of 32, negative 2 is not included. The answer is 2. Again, because 32 can be expressed as 2 to the power of 5. So 2 is a power of 5. Check. Okay. So find all cube roots of negative 64. I want you to look at it and try to have focus on this. So cube root of negative 64 will give us x cubed is equal to negative 64, or it reminds us about the concept of x cubed is equal to negative 64, which gives us x is equal to negative 4, because negative 64 can be expressed as negative 4 cubed, not quantity, okay? Not quantity, negative 4 cubed. So that's why x is equal to negative 4. What about this one, number 4? Find all the fourth roots of negative 625. So to find the roots, of course, it can be written in a radical form or expression rather as fourth root of negative 625, which gives us, or which reminds us about the exponential form on it. Not exponential form on it. What I mean is the perfect fourth power of x to the power of 4, which is equal to negative 625. That gives us no solution. Why no solution? Because as you can see, there is negative, for a while, there is negative sign inside in the radical. What will happen, sir, if there is negative sign in the radical, or in the radicand rather, or expressions inside in the radical? Always remember, when once the radicand is negative for the square root and even in the fourth root, I want you to remember that it will give you an imaginary solution. That's why the answer there is your x is no solution. Even if you use different ways on how to get it, you will still come up with an imaginary or not real solutions. What is imaginary number? These are numbers or square root of negative 1. That is considered as imaginary number with I. So that means they are not real. So we meaning to say their numbers have I, okay? So they're really different. They are not part of the sets of real numbers. Please take the note of that. So now, so we are going to review more or talk more about um, this one, the nth roots of A. Just a recap. Sorry. So we all know that n, there is the index. A, what is inside in the radical or expression inside in the radical is called radicand. So types of real roots is, as I mentioned a while ago, cases, we have the number of roots and examples. This will just guide us soon, if not in this lesson or video discussion, maybe sooner or in our upcoming algebra lessons. So odd, when the case is odd, I'm talking about the exponent. When the exponent is odd, then there is one real root, and if it is even plus the radicand, there are two real roots. If it is even, the negative radicand, there is zero real roots, just like what happened a while ago, square root of negative 4, or the fourth root of negative 625, if I could still remember. Okay, so if the radicand is equal to 0, of course, there is always one real root, which is 0. Okay, now let's check it out. Examples number 1. For the example number 1, we have to find all the real roots. For letter A, fourth roots of negative 256. There is a negative, but there is no real fourth roots. Okay, so negative is the negative and then no real fourth roots. Okay, as an application for letter B again, there is a positive roots or two real sixth roots. X is equal to 1 and x is equal to negative 1 in sixth roots of 1. For the cube roots of 125, we have positive and then one real cube root which is equal to or x is equal to 5. So now, I just would like to highlight this one for the rules because it's very important. So now, product property of roots. When we say product property of roots, I introduced it in my previous videos. The nth root of a product is equal to the product of the nth roots, just like this in algebra. When the nth root of square root of AB, then we can rewrite it as nth root of A. What I mean, the nth root of AB is equal to the nth root of A times the nth root of B. So if you have examples here in numbers, the cube root of 16, so we all know that 16 can be written or can be factored as 8 times 2 since one of its roots, 8, is a perfect cube. So you can have it cube root of 8 times 2. That's why you have it here. Cube root of 8 times cube root of 2, which gives us, of course, cube root of 8 is a perfect cube. So we have it 2, then cube root of 2. So that's how you apply this one. This is what we call the product rule that I mentioned a while ago in the beginning in our review for radicals or radical expressions. Another thing also, class, for the quotient property roots. Sorry, I have to clear it up. Okay, quotient property of roots, according to its rule, the nth root of a quotient is equal to the quotient of the nth roots. So if we have its square root of this one, we'll just discuss first the rule. This is the rule, the nth root of square root of A over B. It can be written as nth root of A over the nth root of B. So this is the rule for the quotient. If you are trying to divide radical expressions, then you can use this one or this rule of radical. Then after that, we have it square root of 25 over square root of 16. Applying the rule, this one. Okay. So that gives us square root of 25, which is 5, check. And square root of 16, which is 4, check. So our answer is 5 over 4. So that's how you apply the properties of radicals, especially the product and then the quotient rule. I hope you can follow all of these. Okay, let's try to simplify radical expressions. So to simplify, for the fourth root of 81x to the power of 12, again, look for factors of 81 and x to the power of 12. That gives us or divisible by 4 when you divide it. So 3 to the power of 4, 81 can be expressed as 3 to the power of 4y. This is what I said, express it as divisible by 4. We all know that the index, when you rewrite it as, or when you rewrite the radical into exponential form, your index will be your denominator. That's why I told you your power in here must be divisible by 4. So all are divisible by 4. Where did we get it? By getting the factors of 81 and x to the power of 12. It's fine that you don't need to factor square root x to the power of 12 since it is divisible by 4. You can divide it right away. So now, next, after that class, we will have it. Fourth root of square root of 3. You can separate it actually so that you will be able to get its simplest form right away or to evaluate it in an easy way. So we have it, of course, we all know that as what I've said, you can just divide the exponent if it is divisible by the index, the exponent of the radicand, if it's divisible by the index, then you can just cancel it out. Cancel, 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 cancel. So what will be left will be 3x. So 3x and 1, 3. Let's see if our answer is the same. Yeah, exactly. So 3 times x times x times x, and that gives us 3x cubed. Okay. I hope you can follow. It's so easy, right? What about number 7? Let's try number 7, class. Okay. So in here, same process, same thing. Since it is a fourth root, so we have to look for or express the radicand in the fourth root so that it will be easier for us to cancel or simplify it. Same as how we do it in the previous example, number 6. So we have it. Why is it 2x squared, sir? Because 16 can be written as 2 to the power of 4. I'll rewrite it. 16, as I have said, this is can be expressed as 2 to the power of 4, which is divisible by 4. You can cancel it out. And x to the power of 8, 8 is divisible by 4, so 8 divided by 4, so that becomes, this becomes 2. That's why we have 2x squared. Okay, then fourth root of 5. So this is our problem now. Our problem now in here is what? To simplify the denominator. So how do we simplify the denominator? Because it has a radical sign, or it is in a radical expression form. So what will we do, class? We are going to rationalize the denominator by multiplying both sides by by the fourth root of 5. So of course, I'll multiply it, fourth root of 5. So why is it redundant? So you can just multiply it by this. Okay, just focus on this. The fourth root of 5 to both numerator and denominator. So now you have it. You'll get this one, uh, 2x squared, then fourth root of 5 cubed. Okay. Why is it like this? Okay, I'll just highlight this one. Why is it, why did we multiply it? Okay, I'll highlight this one. Why is it, it's 3? Actually, as what I've said, focus on the denominator. 5, a fourth root of 5 can be written as 5 to the power of 1/4. So we all know we are going to, in order to make the denominator a rational number, we multiply it by, or we should make sure that we're going to look for, same with 5, having as a base of 5, to make this expression real. So of course, we are going to have a fractional exponent here. Same denominator 4. And what do you think will be added in here? So that if this is 4, we all know this is a product rule. So what will be added in here? What will be in your numerator in this expression that we are going to multiply, so that the result will be a real number. So of course, this is a product rule of exponents. So what is your numerator here to make it divisible by 4? Of course, 3. Why 3? Because 3 plus 1 is 4. Divided by 4, that gives you 5. So meaning to say, what will be multiplied to both numerator and denominator is this. You can rewrite this one, this expression, as a radical form. So we can rewrite it as fourth root of 5 cubed. That's why, that's why we have to multiply this one, we have to multiply it by both numerator and denominator by fourth root of 5 cubed. So that gives us, multiply it by fourth root of 5 cubed, both sides. Fourth root of 5 cubed. So when we multiply this one it here to the numerator class, that gives us 2x squared. That's why we have a 2x squared fourth root of 5 cubed. And here, of course, we solved it a while ago. This one, when we multiply fourth root of 5 cubed, multiply it to the fourth root of 5 cubed, of 5 rather, that gives us a number, or a real solution, which is a real form, which is 5. That's why our answer is fourth root of square root of 5. You can cancel it, and that gives you 5. Let's see in the next solution. Very good. This is what I said. So this is the correct answer. What I mean, the final answer. Do not forget. So in short, class, you can use the concept of a fractional exponents or a rational exponents in simplifying radicals, especially in rationalizing radicals. So I hope you can follow. So let's have more example for number 8. Fourth root of 16x to the power of 4. That gives us, yes, a fourth root of 2 to the power of 4 times fourth root of x to the power of 4. That gives us that one, applying the product property in radical expression. So you have it, cancel the 4, divisible by 4. So what will be left is 2 times x, and that gives us 2x. That's our final answer. For number 9, this one, the fourth root of x to the power of 8 over 3. Then we have it fourth root of x to the power of 8 over fourth root of 3. So then as you can see, the fourth root of 3 can be multiply both sides by fourth root of 3 over fourth root of 3 3 times, as you can see in the red marks. So you have it fourth root of 27x to the power of 8 over 3. That gives you fourth root of 27 over 3x squared. So that's our final answer. For number 10, this one, of course, you have same, this one, very interesting. They have the same. So what will we do? Just copy. It's like telling us x to the power of 7 over 3, multiply it by x to the power of 2 over 3. Oh, see? Product rule. What's the product rule of exponents? Copy the base, add the exponent. So 7 plus 2 is 9 over 3. And that gives us x cubed. Let's see if our answer is the same in here. So the cube root, that gives you 7 plus 2 is 9. So x to the power of 9. Then cube root of x to the power of 9. And that gives us x cubed. So same answer, right? This is what I said. Using the fractional exponents will help us understand also about how we simplify radicals. Assume that all variables are positive, okay? So that's, sorry, I thought it's done already. For the rational, okay. Let's go on with our rational exponents. So when we say rational exponents, exponents having a fraction in form. That's why we call it rational exponents. Expressions having an exponent of fractional form. So that can be, that's what I've said. See, I just want to highlight this one. Look at the numer. Oh, I guess this is something wrong. There is something wrong in here. This is not the right one. It must be m. The index must be the denominator. So please be corrected again. That could be, this must be written as mth root of a to the power of n, where your index m is in your denominator, and then the numerator will be the exponent of your expression. So I want you to remember that one. So if we have negative 8 raised to the power of, or close quantity, 5 over 3, then as you can see how we rewrite it. So this is wrong again. This must be m, and this must be n. Sorry for the inconvenience. For this one, see, try to look at the negative 8 is the radicand, the base is the radicand. Look at 3, the index, the denominator of a fractional exponent is your index, and then the numerator of a fractional exponent will be your exponent of your radicand, and your radicand, your base is your radicand. So I want you to look at the pattern, observe, and how do we rewrite a fractional exponent expression into, or an expression having a fractional exponents into a radical expression or form. Let's have another. So that, or that can be written as this one, fifth root of the cube root. What I mean, the cube root of negative 8 quantity to the power of 5, which gives us negative 2 to the power, because 8 can be written, or can be, can be written in the form of negative 2 cube. So that's why we can have it negative 2 to the power of 5, or quantity to the power of 5. That gives us negative 32. Okay? So that's using the rational exponents in simplifying radicals. So write the expression in a radical form and simplify. Let's have this one. Method 1, evaluate the roots first. So we have it, a cube root of 64 to the power of 1. We rewrite it in the fractional exponent, we rewrite it in a radical form. So that gives you 4 to the power of 1, and 4 to the power of 1 is 4. So method 2, okay, the cube root of 64, another method. This one, we just right away use or rewrite it. what is inside. So cube root of 64 to the power of 1. And express 64 as power of 3. What I mean, a power of 4. So that can be written as 4 cube. That's why 4 cube, this one, what I mean is this one can be written as a fourth power, cube root of fourth cube. So cancel, that gives you 4. Okay, I hope everybody can follow. So 4 to the power of 5 over 2, that gives you method 1, the fifth root, a square root of 4 to the power of 5. So 2 to the power of 5, that gives us 32. And this one, method 2, we have it, the square root of 4 to the power of 5. Then 1024, the square root of 1024 is 30. This is just the same thing. But the method 1 is it's shorter compared to method 2. For number 13, so you have it fourth root of 625, quantity cube. So you have it 5 cube. So 5 cube is 125. In method 2, you will simplify the radicand. 625 cube, that gives you 244,140,625. So long. Okay? So we have it, we get the fourth root of 2 of that, of the radicand. That gives us 225. Still the same thing, but it's a long method. So in short, these are the things, or these are the this is how we can also simplify a rational exponent. So I hope everybody learned something about our lesson for this video discussion. It focused more on the rational exponents, how we use the rational exponents in simplifying radical expressions, or how do we use radical expression in simplifying a fractional exponent. So always remember that when you are confused sometimes in simplifying radicals, you can rewrite it in an exponential form, having a fractional exponent. Okay? So I hope everybody enjoyed the topic. So thank you so much for listening. Please do not forget to watch before you subscribe. And again, thank you to those who are continuing to support my channel, and even who made to the end of the video. Okay, so last part of the video rather. So please support my channel. Watch first before you subscribe, and you can share it to your classmates so that they will be able to learn a lot of things about mathematics. So math is fun. The essence of mathematics to make simple things complete, not to make simple things complicated, but to make complicated things simple. So that's it for today. Thank you so much for listening. Have a good day. Let's have some coffee once again. My coffee is cold already, so I have to drink coffee. Thank you for